final presentation for today, Gabriel Adauto. Good, thank you. On why a 6-year-old is better at my learning game or his learning game than a teacher. Gabriel's mission is to instill in learners a sense of wonder and empowerment that motivates them to combine math, tech, and creativity in their everyday lives. As CTO of Motion Math, he's led the development team to release 9 award-winning iOS games. Android as well? Just iOS.
We have 2 games on Android.
9 iOS games that define fun learning on mobile. Gabriel has 10 years enterprise software development experience before the past 5 years in games, and don't mess with him because he taught Muay Thai kickboxing for a couple of years. Over to you.
All right, thank you. Cool. I don't know if you've done this with your children or godchildren, but my goddaughter was actually 7 when she played this. So this is my dad and my goddaughter, Monica. I come from a family of teachers. My dad is a teacher, all-around great guy, and a few months ago he showed my latest game to my goddaughter. Within about 30 seconds, she had whizzed through the tutorials. Half an hour later, she made it further in the game than he had. So he gives me a call and says, "Son, I don't understand. Why can she get further in your game than I can?" And I told him, "Dad, it's okay. We make these games for kids, not for adults." So I'd like to talk a bit about how we got here. By order of introduction, I'm Gabriel Adauto, co-founder and CTO of Motion Math. We make games that let kids play with numbers. Our mission is to inspire in kids a delight in challenge, particularly in math. I grew up with 2 passions, engineering and teaching. I ended up studying at Stanford computer science, did enterprise software for a few years, but in the meantime also taught computer programming and video game design to kids. I went back to school to get a master's in education, and that's where I met Jacob Klein, born entrepreneur and my co-founder, as well as 2 other key members of the team, Quorum, our head of analytics, and Ignacio, one of our main game designers. I'd like to talk about the learnings that we've had since then. In one of our first user tests, I remember sitting down next to our user tester. We'd spent the night before trying to figure out what's the best way to convey how to play this game in as short a sentence as possible before they press the play button. So I sit next to her and she reads it out. "Move the fraction ball by tilting." This is an accelerometer game. So the fact that she couldn't read that word, I was like, oh my god, she's not going to get the game. She presses play, and sure enough, it's very difficult for her. Not so even the game mechanic itself, not to mention the learning mechanic. And so at that point, but even worse, at the end of this user test session, she tells me, "This was one of the funnest games I've ever played. I really enjoyed it, and I'm definitely going to buy it when it comes out in the App Store." So I learned 2 things in this. 1, kids aren't very good at words. 2, they won't necessarily tell you to your face whether they're going to like your game or not if you're sitting there right there next to them. So to solve this problem, we actually took a turn from this independent game called Braid, where it's like a Super Mario style game, but the cool thing that really stuck out to me when I played this game is I didn't know how to control it and realized just fiddling with the controls that the game had already begun. It was just already in the gameplay. And so that's one of the things that we really started doing with our games. So this is kind of the opening screen. There's like a little title before it, but this is effectively the first visual of the screen. And we have the kids practice the game mechanic before we introduce the math. So you see that there's no math in this. As they play, there's 3 levels of scaffolding. One is just this exploratory section. The second one is this hand that kind of moves back and forth and tells the player how to play. And then third and last of all, we put in words to actually explain what to do. The first 2, about a quarter of the kids even need the first tutorial. They can't stop moving, so they're already moving the game around and understand the gameplay. In contrast, I think only about a quarter of adults can play this game before getting to this screen that tells them what to do. So the next example I'd like to talk about is in our game Cupcake. It's a little bit more subtle. This is the opening screen, and the goal is to run a cupcake business. Now I'm going to show you how we try to convey what to do on this screen. Oh, I got out of sync. Okay, I'm doing it on a slide, it actually pulses, but a lot of kids know how to press on this, whereas adults, and this is the first game experience there, are looking to see some kind of tutorials or words to say what to do in this situation. I attribute this to two factors. One, there's just this psychological difference between adults and kids, where kids are more exploratory and curious about what they can actually try to touch on this screen. The second part, though, is that kids nowadays. Oh, sorry. I'll just talk louder. The second thing is that kids, they actually understand the language of video games. So when things are moving or pulsing in the screen, they're more apt to touch them. I'm going to switch to some features inside the game now. This is our game Motion Map Pizza. Kids set the prices of their pizzas and then take customer orders and enter in the values for them. At the beginning, these orders were just random. We had, there's order one pizza, order multiples of pizzas, and then do these. This, as you can see, this is an addition and multiplication problem. We had them going randomly and excluded the younger kids from this experience. So what we did to solve this problem was introduce a level ramp. Do people know what a level ramping is? Just increase the difficulty of the game over time. It solves three problems. One, the game changes over time, as a good game does. You don't want to have the full experience up front. Two, what we did with the level ramp is we try to always push the kid to be slightly higher level than they're there. So as the kid gets through the game, they progress in difficulty. The thing is that we learn from that is if we figure out that kids are struggling because they're getting answers wrong, you can't have a smooth slope back down in difficulty. We actually drop it very quickly and far, so that kids, the experience of the game is it gets more difficult, and then when they can't handle it, it slows down for them. Now let me talk about the adult experience of the game. So we do get complaints on the App Store and reviews for this because a parent plays this game for a while and they tell us, oh my god, I was playing this game and there is no way that my kid can handle these problems. And the funny thing is that they're just not putting, and how could they even really figure this out, honestly? But they can't put themselves in the mindset of the kid, and the adaptiveness is adapting to them. Now, rather than thinking of adaptivity as something that has to happen in all games, I really think about it as a tool that needs to be used sparingly. The converse actually exists if parents play for 30 seconds. So in Wings, which is another game of ours, I'm missing that slide, but that's okay, we do multiple representations of multiplication. We have arrays, clusters, rows, up to multiplication problems, all the way up to double-digit multiplication problems where kids are just really doing more strategy than they are knowing the answers. In this game, if a parent plays it for 30 seconds, then they may or may not understand, they may tell us, no, this game isn't for my kid, it's either too easy or too hard. So if a parent plays for a long time, they run into the problem of it adapting to them. If they play it for too short a time, It's difficult because they might, if they picked an easy level, then they're going to be like, no, my kid knows their multiplication, they can't play this game. If they play a super hard level as well, it's difficult for them. We actually did an A/B test on this and found that it was better to allow users, this is when it was free, to sample the easiest and the hardest level and just those, nothing in between, because it gave them the best picture and monetized the best. So the next example I want to talk about, I think I need to discuss my point of view, as Jim said in his earlier talk, about what our games are, about what makes a really good learning game. So in the 80s, there's two people, Malone and Lepper, one was a Stanford professor, another was a Xerox PARC researcher, wrote a seminal work, in my opinion, called Making Learning Fun, a Taxonomy of Intrinsic Motivation. In it, they talk about how to endogenously integrate learning into gameplay. In other words, the game mechanic supports the learning mechanic. I realize that's jargony, so I'm going to use the kind of metaphor of it that, the best metaphor for this is chocolate-covered broccoli. I really dislike when games separate have kids do math problems and then separately either reward them with a sound effect or something, or even worse, send them off to a mini game that's actually fun. Instead, what we want to provide kids with is fresh strawberries. We want the game mechanic to be part of the learning mechanic. And the way we do this with math is that people don't play games because games are easy. People play games because there's some difficulty or challenge in it, and we just allow math to be that challenge. Now what that means is that for every learning concept that's there, we need to make a very different game to engage in that concept, because a game that intrinsically handles multiplication is different from a game that handles measurement, is different from a game that handles fractions, or place value. I'm going to talk about our place value game, which is Zoom. Let me show you just quickly for those of you who have never seen it. Let's see. So in this, you see this is the world's most interactive number line. Things I want you to notice is that we don't hide the math in our games. The math is part of it. The numbers are there. Numbers are what you have to interact with to find a goal. The goal of this game is for kids to find particular numbers. And on the number line, hold on, let me just start. Wow, I recovered. That's great. So the goal for a kid is to find a number. Now, the difficulty that we have showing this game to adults is that we're so far, every one of us here is an adult, and we're so far removed from remembering what it was like to not know the relationships between numbers. So the idea that a kid would find interesting that, 100 is actually bigger than 88, because I learned that, well, 8 is bigger than 1, so maybe 88 is bigger. This kind of exploration and new concepts for them is really exciting. But like I said, it's difficult for us to convey that to adults. So what is a learning game developer to do? Do we put in some features for adults to help, or do we continue to really focus on helping kids learn? One of the games that we did to somewhat address this was this game called Questimate, where it's kind of like a game show, but the players make up the questions and then answer them. We wanted this style because the game is actually best played between kids and ideally one or more adults. For the kids, they're into games, but the adults provide facilitation or articulation of what we're trying to convey. So in this game, you'll pick things like, how many jelly beans are as long as a skateboard? Or how many lava lamps tall is a telephone pole? Now, these are not problems that they're really engaging in their math class, and so an adult needs to be there to kind of facilitate it. Now, this is great at the start while the kids are playing with adult, and then the kind of kids start to understand the gameplay mechanics that we put into it, which is also one of the slides that's missing. So we put in these power-ups that are power-ups like, my favorite ones are the mischief ones. So lightning round that makes, instead of giving you the normal 30 seconds to play, you get 5 seconds. On some of the problems, to enter it in, you have a calculator, and whenever you press a button, all the numbers switch on the calculator. So the kids understand the game part of it and start to use it. And then there's this moment in playing this game as everybody kind of passes around the iPad where someone hides it from the other people. And in that moment, it changes the full game for everyone else. I'm gonna... Cool. So at a high level, how does a company, an independent game company, handle these UX challenges? How do we convey to parents the importance of what we're doing and why we're not making features to make it easier for them? We actually found our answer a couple years ago when we were looking at revenue that was coming out of our games. We realized that over 50% of our revenue was coming from teachers. Now,
That's my calendar.
Alright, got it off. We realized over 50% of our revenue was coming from teachers. Now, Gabriel, you say, but your thesis is that kids play your games better than teachers do. That's true, but there's two things that teachers have that parents don't necessarily, that parents have differently. One is motivation. For parents, the primary reason that we found that parents get a game is as a babysitter, is for its entertainment value. Compared to a teacher, where the primary reason they're looking at these games is because that's their job, to teach. Secondly, because they're looking for things to teach, a teacher their expertise lies in there. So they recognize very easily the endogenous elements that we're putting there and why we're doing the scaffolding that the way we do it in the game. So this is basically where we are in our 5-year history. We're making games that are as intuitive. Oh, sorry. The one thing I wanted to say else about teachers is that compared to a parent seeing our app on the App Store, if a teacher says to a parent, hey, I think your kid would really benefit from this app, the price point just effectively does not matter anymore. So that's what we're really focusing on right now. Making games as intuitive as possible for kids, covering math's toughest concepts with endogenous mechanics, and building a community of teachers to help evangelize to all the parents in the world. That's the end of my talk. I'm happy to take questions. I'm particularly interested in the technical aspects of it or how you build this, but I'm willing to answer on any part of the business.
Gabriel, thank you very much.
Yeah. You've got the question down?
Yeah.
Okay.
Hi. Well, my question is possibly slightly outside your area of interest, but because I'm teaching very much remedial math for college, and I was wondering if there is a way to transform your games for adult or young adult learners who don't really know basic concepts of math, but like we're game for sure. So if any potential, like for example, adding fractions or something like that.
Yeah, that wouldn't be the first time that I heard that asking about our games used in those higher level, higher learning contexts for remediation. we try to make our games so that they're fairly gender neutral, which I hope makes them like Mario, just even age neutral. I think users can learn from them, and certainly Questimate, the kind of game show game, that game is higher than our normal K through 6 focus. It's really 5th to 8th graders that enjoy that more, so I don't see why they couldn't use it. I think the other question that you might be asking in that I get a lot is, can we do this for higher concepts? And endogenous integration of learning into gameplay is certainly something that can be done. There's a company called We Want to Know that I really respect. They have 2 games out, Dragon Box and Dragon Box Elements, which are on algebra and geometry, that are just fantastic games, and I think I look forward to filling out the rest of the curriculum at that level in the future.
Okay. Thank you. That brings our day to a close. 6 p.m. presidential suite for kids' track drinks. Hope everybody can join us there, and I'm sure Gabriel would be happy to answer some more questions outside the room. Thanks everybody for their time today, and thanks to our speakers who still have them here for sharing such insights in respect to business for us. So, thank you.